Hi there guys, and welcome back to the second part of question 8, and we're going to look at parts C and D. What I particularly like about this question is if you haven't got a clue on A and B, it doesn't really matter because they're giving you what you need to differentiate. You just got to go with it. Okay, so we're asked to use calculus, so differentiation, integration, to find a minimum value of S. And you should know now by all minimums and maximums, the gradient at this point is going to be 0. And we need to differentiate to find the gradient function of any graph. Okay, so that's what we're going to do. So I'm going to write out S in the correct form. At the moment, this is not easy for us to differentiate. So I'm going to write half at the front. Just find that much easier than leaving it in this form. Plus 16,000 root 2's. But divided by x, we can write as x to the minus 1. Okay, so we're going to differentiate with respect to s and x, so it's ds by dx. So 2 halves, well that's just 1. We're going to have x. Now that's going to become minus 16,000 root 2's. And x, if we subtract 1, we're going to get minus 2. Okay, let's put it back in this form now, because we're going to be using this to substitute in, I'm sure. So x minus 16,000 root 2's, and just like before where we took it out to a negative, we can put it back into this fractional form, so that's going to be x squared. Okay, and because we know the gradient is 0 when it's stationary, we can put it equal to 0. Okay, so we now need to just mess around, rearrange this and see what happens. So let's get rid of this division first. It's times by x squared to every term, so that's going to be 0 still. That's now going to become x cubed, and that's just going to leave me with 16,000 root 2's. Okay, so if it's quadratic, we would factorize now. Because it's this cubic, what I'm going to do is pop that on the other side. So we're going to have a positive 16,000 root 2's is equal to x cubed. Now let's find x. At this point, let's just type that into a calculator, do the cube root of all of that. And you should get, I believe, 20 root 2's. So I'm just going to underline that key bit of information. Okay, so we know where the minimum is going to occur. We know the x value has to be 20 root 2's. We've now just got to find the minimum value of s using this formula. So s is equal to x squared. So it's going to be 20 root 2 all squared over 2 plus this 16,000 root 2's over our x value, which is 20 root 2's. Okay, so let's deal with this bit on the right first. So we can cancel those out. We can also divide by 10, and that's going to leave us with just 800. Okay, 20 root 2's times 20 root 2's. Well, 20 times 20 is 400. Root 2 times root 2 is just 2. So it's going to be 800 on the top. 800 halved is 400. So we can say that here s, the minimum value of s, is going to be 1,200. Now we just have to prove that it is a minimum. So I'm going to use the second derivative. You can use a different value, but I think it's a bit harder. When the numbers are a bit more complicated like this, it's just a bit harder. So let's change color for this part D now. Let's do d2s by dx squared. So let's use it in this form here. So that was the original one. So that's just going to be 1. It's now going to be plus 32,000 root 2's x to the minus 3. Let's rewrite that. So we've got 1 plus 32,000 root 2's over x cubed. That's d2s by dx squared. Okay, and we're only really interested when x is 20 root 2. So when x is 20 root 2's. Let's see what happens. So we're going to have 1 plus 32,000 root 2's, and that term there is divided by 20 root 2 all cubed. Okay, so you can grab your calculator now and go for it. I like to leave that friend alone. So I'm gonna do this. Just waiting for my computer to catch me up. So we're gonna have 1 plus, well, 20 times 20 times 20, that's 6,000. And root 2 times root 2 is 2, but then another root 2 would be just 2 root 2's. Yep. Okay, so that's going to give me 12,000. Sorry, I just had to check that for a minute. It's going to be 12,000 root 2's. No, it's not. Well, that's embarrassing. I said 2 times 2 times 2 is 6, when you all know that that's going to be, let's get rid of all that, that's going to be 8. So 20 times 20 times 20 is going to be 8,000. Root 2 times root 2 is going to be 2, so that's going to be 16,000. And that extra root 2 there. Okay, so we're going to have 32,000. Just to show you, maths teachers also make mistakes, but I check my mistakes. So it's going to be, there's another one. Okay, so we can cancel out these root 2's. We can divide by 100, and so we can see that is 20. So 1 plus 20 is 21, and that's positive. Okay, so that's positive, and that's greater than 0, which means it's a minimum, because after the stationary point we're expecting it to be a positive gradient and greater than 0. Okay, so so if we say d2s by dx squared is positive, therefore greater than 0, therefore it's a minimum. Okay.